In this lesson, you're going to learn how to create joints in Fusion 360. Joints are a way to control motion between two components in your design. To learn how to create joints, you're going to basically recreate what's on the screen here, which will give you an opportunity to see how the 7 different types of joints work. Your submission for this assignment should include both of these objects that you see on the screen with your joints created. And as we go, don't worry about trying to make the dimensions of your objects match mine exactly, because what's most important is that you understand how to create the joints and manipulate them. So let's get started. We're going to start by creating this object on the right, which looks like a shaft coming out of a wall, and an object that's swinging on the shaft. Rule number 1 when you're creating joints is that joints only exist between components. So if you want to create a joint between two objects, they have to be components. The two components in this case are the wall with the shaft and the swinging object. So with that said, create a new component for the wall and shaft. And make sure its parent component is the main component. Let's activate this component so that the new sketch that we create will exist inside of this component. And remember, your dimensions don't have to match mine exactly. Just make something that looks similar. Now that the wall and shaft are complete, let's create another component which will represent the swinging object. Make sure its parent component is the main component. Activate it so that we can design a sketch that will appear inside of this component. Create a sketch on the front plane of the shaft. Notice I'm projecting the shaft onto the sketch because the swinging object's design is based on the shape of the shaft. I want the swinging object to wrap perfectly around the shaft. Once you're done with the sketch for the swinging object, extrude it slightly. You should now have two freely moving components, which takes us to rule number 2. In order to create a joint between two components, at least one of the components must be grounded to the parent, meaning it can't move. It has to be anchored. It serves as the anchor for that object. In this example here of a backhoe, which you'll be designing later, we have a bunch of parts that are free to move. The only component that's grounded to the parent is this object here, which is stuck in place. Everything else moves around it. So for your design, I want you to ground the shaft component by right-clicking the component in the browser folder and clicking Ground to Parent. Now that the shaft is anchored in place, let's create a joint between the shaft and the swinging object. To create a joint, click the Assemble drop-down and then click Joint. You'll notice that there are 2 tabs in the Joint menu. In the first tab, which is the Position tab, you must select the location on each component where they will meet each other. This is where the joint will exist. We refer to these locations as the snapping point for each component. The second tab, which is the Motion tab, is where you determine the type of motion that's going to exist between these two components. And there are 7 different types of motion. Before we determine the type of motion, let's set the snapping points for these components. Notice the swinging object sits directly in the middle of the shaft. So in other words, the center of the hole in the swinging object is directly at the center of the shaft. So those will be the 2 snapping points for these 2 components. the center of the hole, and the center of the shaft. So let's select these two locations for each component. There are several ways to select these locations. The first way, which is the easiest way, is called simple mode, where Fusion 360 automatically highlights locations on the objects where it would make sense to create a snapping point, like directly in the middle of the shaft, or at the front of the shaft in the middle of that circle, or directly in the middle of the hole for the swinging object. If you're trying to select a location, but when you move the mouse toward it, it disappears, first put the mouse in a location that will make the snapping point appear where you want it, then hold the control button, then move the mouse to that location, and it shouldn't disappear anymore. The other way Fusion allows you to select the snapping point for a component is by using two faces that equally span across from where you want the snapping point to be. This mode is called between two faces, and it really only makes sense to use when the snapping point that you're trying to select is floating in air, or if it's in the middle of an irregular shape. For example, if this was the swinging object, the location I would have to select is between these two faces, right where the center of the circle exists. Since my mouse can't click there, I'd have to use the between two faces option to select this snapping point. For your swinging object, you could either use simple mode or between two faces to select the center of that hole as the snapping point. Now go over to the Motion tab and select the type of motion that should exist between these components. Rigid will keep the components in place and not allow them to move relative to each other. Revolute will allow one component to revolve around the other. Slider will allow one component to slide across another component on one axis. Cylindrical will allow one component to both slide and revolve around another component on the same axis. Pivot allows one component to rotate and slide on another component, but on two different axes. Planar allows for one component to rotate on another component as well as slide on both the X and Y plane of the other component. And the ball joint rotates a component around all three axes. Think of it like your shoulder joint. For this component, I want you to select Revolute as your motion type. As you can see, there's an option here to change the axis that the revolution occurs on. It's up to you to select the right axis. Below that, you'll see motion limits, which allow you to select the maximum and minimum positions the joint can exist within. The option that says rest is where your object will bounce back to once you're done moving it. Check minimum. Then you'll see this blue thing here. If you drag and slide this blue piece, you'll notice that the value for your joint position changes. You can use this value to determine what your minimum, maximum, and rest positions will be. Make sure that the minimum has the lowest or most negative number and maximum has the highest or most positive number. And if you want to see what this joint looks like in action, hit the play button where it says preview motion or preview limits. And now for the ball and socket. Create a new component and name it socket. Make its parent component the main component and activate it. Create a new sketch within this component. In this sketch, create a square, and at the center of the top line of the square, create a circle that does not extend beyond the sides of the square. Then finish sketch. Extrude the square symmetrically until it looks like a cube. Then use the revolve tool to carve out a spherical dent at the top of the cube. You've just created the socket component. Now anchor it in place so it can't move. In other words, ground it to its parent. Now let's create the ball component. Create a new component and name it ball. and make its parent the main component and activate it. Create a new sketch on the top surface of the socket. Create a circle at the center of that dent that perfectly matches the size of the dent. Then draw a line that splits the circle in half. Then create a smaller circle inside the larger circle. Click Finish Sketch. Use the Revolve tool to revolve half of the larger circle around the center line to make a sphere. Then extrude the smaller circle to come up through the sphere and join those two bodies. You should have a freely moving ball component. Now create a ball joint between these two components. By selecting the top center of that dent and the center of the sphere as the snapping points.